Then we move on to model building and evaluation. So we begin this by using it from a scalar law matrix, import accuracy score, classification for fusion matrix, Roche accuracy score, and curve. So then we move on to define, evaluate, model X train, X test, and Y train and Y test. Basically, this defines the evaluation functions for each of the models that we're gonna later use in this project, such as like logistic regression model and the random forest classifier. Next, we move on to model fit train, X train, and Y train. Then we move on to y predict is equal to model.predict x test. Y prob is equal to model prob predict prob x test 1 if has attribute model predict prob else none. Basically, what this line of block of code does, it makes predictions for like the function for each of the model. Then we move on to accuracy is equal to accuracy score, all the way to like EUC is equal to raw CS score equal y test and y prob if y prob is not in null else null. Basically this line of code basically calculates the metrics for each of the models for like accuracy, report, and AOC. Then we move on to return accuracy as AOC, classification as a report, under area under the curve as AUC, and then yprob as yprob. Next we move on to using the models. So from sk.linear model import logistic regression, from sklearn.ensemble import random forest classifier. So the models are equal to random regression, equal to logistic regression with these parameters, random forest with a random forest classifier with these parameters. Basically what this block of code does is it defines like the models to evaluate, and it creates like a dictionary of like the machine learning models to like compare later on. Then results is equal to empty brackets. Basically there's like an empty dictionary to store all the evaluation metrics. Then we have for feature set name x train x test, y train, y test, and train test data items all the way till results model dot name is equal to model result. Basically what this block of code does is basically evaluates each of the model with like each of the feature sets, such as like our ordeal features, ordeal plus scaled, all the way to like all features. Then we move on to like displaying the comparison of the model of each model performance. So performance df is equal to pd.dataFrame columns is equal to model all the way to area under the curve. Basically this creates like a data frame with like the columns for each key performance matrix. Next we move on to row is equal to 0 for model name, model results, and results on item, for feature set name metrics and model results on item, all the way up till like row plus and equal to 1. Basically what this block of code does, it basically uses nested loops over here to extract like all the metrics for each of like the model features, such as like the accuracy all the way to like the area under the curve. Later on we display each of the models performance based on like their feature set. So then we display it over here by using performance df.sort values accuracies ascending is equal to false. Then we have, so in this we have the model, the feature set, the accuracy, precision, recall, and F1 and area under the curve. The first one is logistic regression with a feature set of like all features with an accuracy of like 0.9, precision of 0.191, recall of 0.91, F1 score of 191, area under the cover of 0.92, all the way down to like we have our random forest with like a feature set of original plus scale with an accuracy score of like 83% and a precision of like 0.85, recall of 0.84, and then a F1 score of 0.84 and an area under the curve of like 0.91. So yeah, so as you can tell, logistic regression models tends to do a lot better than compared to like a random forest models for like feature sets. So this was the entire project. Thank you for listening and watching.